Right, so quick background, they're asking for experience. Experience so far is just on Kaggle. Yep, and then it asks you for the important architectures. So generally with this competition, as is pretty much always done on Kaggle, we use Jupyter backbones. So when it comes to significant architecture, which is this first slide, the Jupyter v3 large base and Jupyter large were all used. You'll see that across pretty much all competitors, they use those. That's really no different than what's usual. Another significant thing when it comes to the features, the way we input the features to the model was prompt question, the student text, which was the answer, and the prompt text, which is pretty much a quick synopsis of what they're supposed to be explaining. That's how we fed it to the model. So this, just to quickly give you a bit of a rundown on this, the models had a little bit of difficulty when dealing with prompt question separator, text separator, prompt text. A lot of the competitors were dealing with prompt question, then just prompt text. They found that to be a little bit easier, and the models would converge a lot better. As soon as you'd add the prompt text and you kind of kick up the max length to a very large size, the models would have difficulty converging. You'd see, the validation would just skyrocket and it wouldn't go down. So there was actually a way to fix that. And I'll bring it over to, give me 1 second. Yeah, here we go. So I explain it kind of in here, the discussion post. One of the biggest tricks for this competition was figuring out how to implement the prompt text. So, this section here is the question, that's the student's answer, and this is the prompt text. And what you had to do is you had to create a head mask. And you can find the code over here. They'll show you how to do the head mask part. This is the second place solution, and this is public code. So you can go in and you can kind of check it out yourself. And there should be a part where I show the head. And there will be, yep, so there's something in here called the sequence puller, and this will pull over the sequences. And this is just mean pulling. So you'll see this used a lot in competitions, this mean pulling head. And that mean pulling head will be in utilities. So if I go here, I'll be able to find it. Yeah, so there's a part which is right here where we get the attention mask. We expand it to the right side and it becomes input mask expanded, and we multiply the last hidden state by the input mask expanded. That part there is really important because that's what actually allowed the models to be able to learn properly and for the validation accuracy to go down when it came to including the prompt text. If you don't do that, you're really only going to have luck with adding the prompt question and the text. And you have to have a head mask. So this head mask is different from the attention mask. The attention mask is obviously ones for everything and then zeros for the padding. This thing puts zeros over the first portion and over the last portion. And it just keeps ones for the middle. And that's only done at the head when we do the mean pulling. That lets the model obviously just concentrate on the student's answer itself. That was really, really important. So yeah, that was probably the biggest thing. The next thing to kind of move on to would be the prompt question augmentation, which was also pretty helpful. So we'll go to the, actually I'll do it in here. And there'd be, actually, yeah, I need to go down here. There'll be code here. So using a large language model. So if you guys get whichever LLM you prefer, what you kind of have to do for this part here is obviously there were 4 questions. You guys will have a lot more questions on your end, but we had about 4 questions that we had to work with. Now, obviously, the issue with that is they're going to be kind of overfitting the questions, these models, if you just give them 4. So this was kind of a way of augmenting it. You go to an LLM and you just say, look, I'm going to give you, this is the original question. So you say, I'm going to give you the original question right here. Please give me 10 different variations of this question. And it's going to go ahead and it's going to give you 10 variations. So here we have 11. We have the original question plus the 10 variations. And if we look at the code down here, we add the prompt question right here. And, you know, if it's not training, we will add the original. If it is training, we add the extra prompts. And when it comes to the random choice, it's just a random choice. There's no like, you know, 50% augmentation, you know, 50% original. It's just random choice. It'll choose randomly between all of these. And that was very helpful in making the model learn better. It did decrease the validation accuracy. Well, sorry, it decreased the metric significantly. So that was very important. Also, another thing that was important, and I don't think I really mentioned this during the write-up, maybe I did, was this part here. So adding these prompts. So we tell it to think through this step by step right before the prompt question. And so we'll tell the model. And then after the separator and before the student answer, we say pay attention to the content and the wording. So prompts like that, it did make it learn a little bit better. So it was helpful. You know, it had a good impact. Yeah, what else was there? Obviously, we used Hugging Face. Training was about 16 hours, so that's pretty important. With a 3090, you guys will probably have better equipment. So important features: prompt question, text, prompt text. Yep, obviously. Yeah, and using auxiliary classes was also pretty important. So I'll go through that now. So what I did with the auxiliary classes, you'll find in here. Yeah, so I have this data set here, which is called data sets for training. And it will show you the auxiliary classes. And the auxiliary classes are just the classes from one of the previous competitions that you guys did. Give me a sec. Just go ahead and find that. So it was feedback 3.0, which is this one here, English language learning. So this is also from the Learning Agency Lab. And yeah, you had your, your cohesion, syntax, vocabulary, phraseology, grammar, and all that stuff. And the idea behind it was just, I got a bunch of models that had already been trained in this data set. And they already knew how to get cohesion, syntax, vocabulary, phraseology, all that stuff. And then what I did was I just got the row text, just the row text, nothing else, right? And that was the only thing that I put into that pipeline. So I had a big ensemble of models that had been trained on data from this competition, which again is your guys' data set. And yeah, I went ahead and I created a bunch of pseudo labels, pretty much. So these are pseudo labels. And I use these as auxiliary classes. So if you'll check the code here, where do we have it? Go to the model head. Yeah, we have a second head here, which is for the auxiliary classes. It's our auxiliary head. So we have the original, the auxiliary head. And if we go down to the training, this code is big enough for you guys, right? You can see this properly? Hello?
Sorry, we were making hand movements that you couldn't see. It's pretty small.
It's pretty small, okay. I don't know how to increase it when it comes to Visual Studio Code, to be honest with you. Yeah, I guess we'll have to do. So Yeah, when it comes to the global stats, so the way you do the auxiliary classes is you're just going to do it every second time. So every second step, you can't be doing it like every single step, because then it's just going to how do you say, overwhelm the original targets. So, you know, when every second step, you're going to have a weighted average of loss and auxiliary loss. And so what was the weighted average? The weighted average was 0.5. So every second step will be doing 50% from both. And the criterion, of course, is L1 loss. And that was pretty significant. That actually helped quite a bit. I feel like that was a pretty important part, because if you don't have that, you know, it makes it a bit more likely that the model is going to start looking at, it's going to start finding overfitting features, you know, stuff about the data which doesn't really translate very well across different labelers. But if you give it all these auxiliary classes, you know, it kind of anchors it to something that it gives it a reference point, so it doesn't start straying kind of off into stuff which doesn't make any sense. So that was pretty important. You know, let's see, other than that, yep, LLM augmentations for prompt text. You went past that bit. Yeah, training methods used, so we use 3 epochs here. When it came to the pseudo labeling, we used 3 epochs, I believe. 1 second. Yeah, 3 epochs, that's right. And yeah, layer-wise learning rate decay was really important. So we used Adam W, auxiliary classes, and layer-wise learning rate decay. So layer-wise learning rate decay changed across each model. The ones that I have here, this is for the LSTM head. And a couple things to note too, is that if you're using the LSTM head, now you can with LSTMs, you can pull over the layers of the model kind of vertically, or you can pull horizontally over the sequences. If you're pulling vertically, you can go for high learning rates. You know, you can bump this up to 1E-4. But if you're pulling horizontally with an LSTM, I kind of find that you should be using learning rates which are a bit smaller. So here at the very tip, we have 2E-5, and then in the head we have 3E-4. So, and then of course the weight decay was like at 1E-3. I usually use that weight decay for my models, except for I think Jupyter large was 1E-2. So yeah, maybe I can show you this real quick. I'll show you the open assistant one. So in all my data sets here, this is public too, so you can you'll probably have access, unless I forgot to share one of them. Yeah, if you go into one of these data sets and you download them, so you know, I'll quickly go ahead and I'll download it. There you go. So yeah, this is using a slightly higher learning rate of 5E-5 towards the tip, and that's because it's using LSTM pooling across the layers rather than the sequences. But yeah, the learning rate's pretty important. For this one, I would usually freeze the bottom 8 layers, usually, and then I would have a learning rate of like, you know, 2E-6 from 8 to 16, and then 2E-5 from 16 to 20, and then 1E-5 from 16 to 20, then 2E-5 from 20 to 22, and then 5E-5 from 22 to 24. But yeah, the layer-wise learning rate decay is almost always like a really, really important thing in all of these competitions. If you're not using it, the score just isn't going to be competitive. You have to save the lower features. Yeah, and very important. But yeah, you can check out any of those notebooks and just download it, and then it can give you a bit of a reference point on what learning rates you should be using, and the warm-ups and the epochs. They're all available there for you to just download and kind of check out. So it goes, did you ensemble? How did you weigh different models? So I just did a normal average. I didn't do anything fancy. I was afraid of doing a weighted average because from my experience, weighted averages can overfit, especially when our public data is very small in this competition. I think we only had like 13% public data. Okay, so important, interesting findings. What set you apart from others in the competition? Yeah, the head mask was very important. We went over that earlier. That's when we were zeroing out the question in the prompt text. So LLM augmentation, pseudo-labels. Okay, that's really important, the pseudo-labeling. So pseudo-labeling was really important in this competition. And if you go into the second place solution here, you're going to find, where is it? Auxiliary. False. Okay. Yeah, it looks like I forgot to upload my pseudo labels. Anyhow, I'll make sure I fill the data set for training with the pseudo labels. I'll upload those. But pretty much, we do pseudo labeling, and the pseudo labeling is really important because without the pseudo labels, we can't train on a very high max length. So without the pseudo labels, I was training on 1,280 max length. But if you try going higher than that, you'd have trouble kind of converging because, obviously the model is struggling to make sense of, you have different labelers and each one's labeling the data in a different way, and that can be confusing for the model. But if you have the neural networks, which have already kind of normalized this, it makes a little bit more sense, and then you can increase the max length a little bit higher. So we're able to go to 2048 a lot easier when we have pseudo labels. Before pseudo labels, I could only do like 1,280. And when it comes to the pseudo labeling, I'll have a method somewhere around here. Yeah, when it comes to the pseudo labeling, it's just a concatenation. So here we have the original training data frame, and then the one with the pseudo labels, which we just concatenate underneath of it. So original training, we just concatenate the pseudo labels underneath of it. And we let the model run on all of those, on that entire combination of the originals plus the pseudo labels. That was very important. That increased the score by a lot. And it also allowed me to train the base model. The base model, so the Roberta v3 base wasn't learning before we had pseudo labels. Okay, if you use Ensemble, was there a single classifier that did most of the work? Which one? So yeah, the Roberta v3 large with LSTM layer pulling, not sequence pulling, layer pulling, did the best job. Where can you find that one? It'll be in this sidebar somewhere. I believe it's version 9. Yeah, it has all the weights and also has the training script. So training script will be there. Yeah, it's also important to note that with some of these models I've been using, I've been getting models which were trained on this competition here, and just reusing those weights. So you can do that too, and that could help you out a little bit, because what the models learned in this competition here is still relevant to the competition we are doing currently, this one here. So yeah, and that probably brings us to the end of it. I'm gonna quickly look at this and make sure I haven't missed anything. Yeah, so this write-up, you'll have all the different scores and everything. And when you're looking for the versions, just remember that if I don't specify the versions here, if you go to this notebook, you'll be able to go down here and find which versions we were using. So this one obviously is version 9. Yeah, that's the best model. Another thing to note, and I didn't mention this because it's pretty small and it doesn't really matter too much, but I did create some extra heads where I just, I got all the embeddings for my model and I trained an extra head, and that extra head wasn't really all that impressive. It's just like a, simple, here it is. You got two linear layers with a GLU activation, and your auxiliary head, and you're just training an extra head and then just averaging out the original head and the new head, but that's kind of not really interesting. So yeah, I don't know. I thought it was exactly what you wanted, but feel free to ask any questions.